Hello, everyone. So I'll be going over section 5.2 today about probability and odds. So a lot of times you'll hear a couple of different ways of basically describing the same thing. So let's say, for example, if you're flipping a coin, you have 50-50 chance of winning, right? So 50-50. Or they would say that you have a half chance. Now, these are both describing the same event, either heads or tails, depending what you call, of course, but they are actually mathematically slightly different terms. Now, of course, they are related because they are describing the same events. This first one is called odds. Half chance is what we call from yesterday probability. So odds, 50-50, half chance, probability. Now, how that is defined in more detail is that the odds in favor of something happening is the number of favorable outcomes against the number of unfavorable outcomes, the ones that you want versus that one that you don't want. So for example, let's say you call heads. Now that means one outcome is favorable and one outcome that's unfavorable. If we were to write this as an odds, you have one favorable to one unfavorable outcome. And that's how we are going to write odds. We're not going to worry about this part here. It is, again, the probability of success against the probability of not success. Um, so in this case, 1-to-1. If we were to write it as the actual probability, you would have gone 1/2 to 1/2, which of course you can rewrite as 1-to-1. Or, of course, 50-50. Now, where 50-50 comes from, of course, is from 50%, which is 1/2, and that's probability, right? So, like we said yesterday, probability is more about the number of favorable outcomes out of the total. So you will write P probability of heads is equal to 1 heads out of 2 sides of the coin. So you can see that they're closely related to each other, but they're not the same. Okay. What I find a little bit confusing is sometimes when you talk about probability and odds and using coin as an example, it's not always the best, but it is so familiar. It's because the fact that it is 1-to-1 or 50-50 or half chance of heads or a half chance of tails. What we're going to do instead for our example is look at other odds and probabilities and see if it can make more sense of what's happening. So in example 1, it says Bailey holds all the cards from a standard deck of cards, and then Morgan is choosing one without looking. So of course, this is going to be random. We're looking at the odds in favor of Morgan choosing a face card. So there are 12 face cards, as you know. And that is coming from 4 jacks, 4 queens, and 4 kings. Okay. So out of 52 cards, then that means there are 40 not face cards. These are aces, twos, threes, fours, fives, six, seven, eights, nines, and tens. So that's 10 different numbers or letters. Or you can calculate it by 52 minus 12 will also give you 40. So given that odds is about the number of favorable outcomes as a ratio against the not favorable outcomes, it will make sense that our ratio in this case will be 12 favorable outcomes to 40 unfavorable outcomes. And of course, if you are given a ratio, you can always reduce this. So you have 3 to 10 odds. And you get these numbers by dividing either side by 4. Okay? And this is called odds in favor. Now, of course, related is the probability of drawing a face card. So the probability of drawing a face card would be there are 12 face cards divided by 52 cards in total, and you'll get 4 out of 13. So you see that the answers are different, so they're different questions. Now, for the next part, we're looking at to determine the odds of against Morgan drawing a face card. Of course, we can use a similar kind of logic from part 1, and that is to say, we have 40 not face cards to 12 face cards, so that will be reduced to 10 to 3. Another way of thinking about it is simply switching around the two numbers to go from odds in favor to odds against. Okay. Now, the description at the top talks about the probability of A not happening and the probability of A happening. For what we're considering, we're only considering either something happens or it doesn't. Now, it doesn't mean that they're both equally likely, right? In the case that we just did, it's much more likely to not draw a face card than it is to draw a face card. But the idea of this complement of events still holds. Okay, so we can still subtract the probability from 1 to find out the probability of something not happening. And that's what that was about. Now, another example, it says research shows that the probability of an expectant mother selected at random having twins is 1 out of 32. So the probability of twins is 1 out of 32, of course. That's given. And the probability of not twins, so anything but twins, again, we put a little apostrophe there, will be 1 minus 31 out of 32, which of course is 1 minus 1 out of 32, yes. So it'll be 31 out of 32. So if we were to look at the odds in favor of an expectant mother having twins, it would be the probability of having twins colon the probability of the expectant mother not having twins. And then we generally would write odds in favor or odds against as whole numbers, so that would just be 1 to 31. So this is odds in favor. Sometimes people call it odds for. And then odds, of course, the odds against is simply the reverse. So we can just flip this over, and the odds against will be 31 to 1. Okay. So now this is all about transforming from probability to odds. What if we are given odds and then we want to determine probability? We use this formula here. If we're given the odds in favor of some event, A occurring as m to n, then the probability of A is m over m plus n. A simple example would be right here. A computer randomly selects a student named from a university database to award a gift card. The odds against the selected student being male is 57 to 43. determine the probability that the randomly selected student will be male. So odds for, or odds in favor, of course, is just same thing but backwards. So 43 to 57, odds in favor. Now, if we were to calculate the probability, that would be 43 divided by the total number of outcomes, both favorable and unfavorable. So that would be 43 plus 57. So you actually get 43 out of 100, which of course translates to 43%. Okay. So next one is not really an odds question per se, but it does warrant some mentioning. Hockey game has ended in a tie after 5-minute overtime period, so we need to decide it by a shootout. Coach will decide whether Ellen or Brittany will shoot first. Um, the coach prefers to use her best shooter first. So we're going to look at the shootout records. So usually you wouldn't do this question with odds, right? So you would just go 8 out of 13 for Ellen, and Brittany went 10 for 17. And you can just divide these and get a decimal approximation is probably best here. So if you use a calculator, you will get 0.615. And then if you divide it 10 by 17, you will get approximately 0.588. So, given that information, it is clear that Ellen should go first. Okay. So from there, the other thing that you want to look at is just the odds in favor of scoring. Just a little bit to mention here. So 5 misses, right? Either they score a goal or they don't score a goal. So if there's 8 goals scored out of 13 attempts, then Ellen must have missed 5 times. Brittany must have missed 7 times. So the odds in favor for both individuals, the first one will be 8 to 5. And for Brittany, it will be 10 to 7. And these are both odds in favor. Now, what you will notice is that these two are not easy to compare, like which is better, odds in favor. So what you can do is multiply so that each one so that they have the same number of misses. So I'm going to multiply 5 by 7, right? So over here, I'm going to multiply both numbers by 7. And for the second odds, I'm going to multiply by 5. And how I got those numbers is just the opposite from each other. So once I do that, I will have 56, the new odds of 56 to 35. And for Brittany, 50 to 35. So what that means is by the time Ellen has missed 35 times, she would score 56 goals. And then for Brittany, by the time she misses 35 times, she will only have 50 goals. So the conclusion is still the same, and that is Ellen should go first. Now, for a comparison question of this nature, it is up to you what method you use. You'll probably prefer to use probability because it's more familiar, and that's okay. Last part. Example 5. A group of grade 12 students are holding a charity carnival to support a local animal shelter. The students have created a dice game called BIM and a card game called Zap. Odds against winning BIM are 5-2. Odds against winning Zap are 7-3. Which game should Madison play? So what is not included here, and it's definitely worth mentioning, is assuming she wants to win. Okay. So very similar to what we did earlier, we're going to look at the odds in favor for each game. So BIM, odds in favor, is actually 2-5. Right? You flip the odds against the other way. And then Zap, odds in favor, will be 3-7. Now, all we need to do is rewrite these as probability of winning. So the probability of winning BIM will be 2 over 2 plus 5, which of course is 2 over 7. And then for Zap, that will be 3 divided by 3 plus 7, and that's 3 out of 10. So even without a calculator, you should be able to find that 3 out of 10 is 0.3. And if you use a calculator, you will find that the probability of winning at BIM is a little bit lower than that. It will be 0.286-ish. So she should play Zap, is the conclusion. Okay, so that's it for today. Um, we'll continue by going over probability of counting methods next. And thank you so much for listening.